Ellie will play against you, okay? And Andy will run it, okay? And it's a more Disney Pixar kind of movie theme Kahoot, okay? And then one is about, since we're doing Ellie's birthday celebration a little bit with you guys today, so you can't ever say I didn't invite you to the party. We'll do, the other one is 10 questions about Ellie. So I will give you a few minutes if you want to put some questions in the chat after a few minutes. And she's on the call with us, so she might answer your questions, okay? Do I have to? Yes, you have to answer the questions.
You said Mike.
And also she will answer your questions, or she won't get electronics time later.
I'm going to do a Kahoot.
Okay, go sit down. All right, so I'm going to go ahead and get started. I'm going to hit present now, and we'll get through. I've got 2 problems that we're going to do, and we'll have the Andy joke break of the day in between the 2 problems. Okay. All right, here we go. And back into there. All right, so we're going to talk about rate problems. The challenging thing about rates is that we have the calculator questions, but I 100% guarantee you're going to see this. Okay, they're going to. So I have to. The examples that we mostly have. I'm sorry, I'm trying to get the pen out. The examples we mostly have are calculator. So I will run you through them. I'll show you the calculator piece in Desmos, so you at least see it. But we're going to not super focus on the calculator part, okay? Whenever I show you something that we get a numeric answer to, it would be something you'd have to integrate or take the derivative of by hand. And so the function will be simpler on your test this year, okay? So it's just kind of the nature of it. But I wanted to start doing rate examples, but that's why I kind of put them off, is because they're mostly calculator questions. And I do have some resources I'll probably start pulling from. If you haven't gone to any of the AP Live stuff, that stuff is having some really good stuff on us being able to do some of these problems with no calculator. All right, so we're going to do 2015 number 1 first. Hopefully you have it in front of you. So I'm going to read it. So the rate at which the rainwater flows into the drain pipe. And we started learning this year that when we see that word rate, we know that that means a derivative. So automatically we know that R of T is a derivative, okay? Flows into the drain pipe is modeled by the function where R of T equals 20 sine of T squared over 35 cubic feet per hour, okay? So this is the, oh, it already says rainwater flows in. That's the rate in. And then the pipe is partially blocked, allowing water to drain out of the other end of the pipe at a rate modeled by D of T equals negative 0.04 T cubed plus 0.4 T squared plus 0.96 T cubic feet per hour. So again, it says the word rate right there, so we would want to do derivative. We know that that's a derivative again. It's the derivative of the draining out of the pipe, again in cubic feet per hour. Everything was over the interval from 0 to 8. And then it says there are 30 cubic feet of water in the pipe at time t equals 0. So again, that right there is what we call the initial condition. And there's a lot, I'm not abbreviating that very well and neatly. There's a lot of different, you're going to use that at least one time in the problem. They use like initial conditions in really interesting ways. The ones, I know BC today saw a whole bunch of interesting ways they used an initial condition. All right, so the first question A just says, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval? So literally they say how much flows in, and they're talking about a rate, right? Or how many, oh, sorry, no, they aren't. How many cubic feet of rainwater flow into the pipe? So we have our rate of rainwater flowing in, and our rate is in cubic feet per hour. But what they want me to actually find is they want me to find what's going on in, or they want me to figure out something in feet cubed. So I have to get, I'm going to write that different. We have the form, or the function is in feet cubed per hour. We've got to get to feet, okay? So the question is, do we have to, there's two processes we're going to do. We're going to take a derivative or we're going to integrate it. So to get rid of the rate notation, we have to do an integral. So that's what we're going to do. So I'm going to integrate, and then we're going to integrate the one that is the, it said it wanted the flowing into. So the flowing into was the R function. If it's something complicated like that where we aren't going to integrate it by hand, we only have to write the name of the function. So you might write the actual function this year if you have to actually calculate it by hand. Though there's probably going to be a lot of things where they don't even give us a function. We've got to learn to see it from a graph. All right, then we're going to go from 0 to 8, okay, dt. Now, I happen to put these into Desmos for us. So let me show you what it looked like in Desmos. Let me go here and here. All right, so I am going to hide that right now. Okay, so there's my two functions. The red one is the RT, the blue one is the DT. All we're really concerned about is RT right now. In fact, I don't really even care about the graph. I'm mostly looking over here. So when I went and I integrated that in Desmos, and to get the integral, you just start typing the word integral. Okay, so if you are practicing, you can use this on the test. I don't think it's going to be necessary. Yeah, I got 76.5703 and so on and so on and so on. So that's the answer that they're looking for. Okay, so we end up with 76.570, and you'd want to label that, okay, because, oh, actually they didn't label it. Oh, because it asked it how many cubic feet of rainwater. So you could say that it is feet cubed, but they weren't grading on that part. So on this part A, the integrand, so this part is worth 1 point and your answer is worth 1 point. And again, you're going to integrate that by hand this year or from a table or a chart of some kind or a graph this year. All right, but you hopefully get the concept of it. They were just looking for the radian and it was an integration. All right, looking at part B. Okay, all this stuff here is just the stem of the question. I just copied and pasted it down. It's asking us, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Give a reason for your answer. Okay. Are there any, Ellie, are you kind of watching the chat for me? Is there anything? No, nothing in there. Okay. If you do have a question, you know, you can come off your microphone and ask, okay? Just stop me. Is the amount of water in the pipe increasing or decreasing? Okay, so when we see increasing or decreasing, typically we think first derivative. Okay, but we already know that these are derivatives because we know that they're rates. So we know that that's a derivative and this is a derivative already because of the word rate. So we already are in first derivative. And we know that if our first derivative is, ooh, that was not the button I wanted, sorry, because I don't have this flipped the right way. So if our first derivative is, so if f prime is positive, we know that it's increasing. If f prime is negative, we know that it is decreasing. So in order to figure out if it's positive or negative, I need to take into account what's going into the pipe and what's coming out of the pipe. So what I'm going to calculate is the rate in, and we did some of these rate in, rate out problems, rate out, at least in the AB class we did. So the rate in, and we're supposed to evaluate that at time 3, minus the rate out, which was the D function of 3. And literally, again, it would be something you could integrate by hand or off of a table or out of a chart, okay? We're going to use our calculator because it was a calculator question. So when I come back over here, that's my D function there. If you look here, I did R of 3 minus D of 3. Remember when if you put this into Desmos, name the function. So I named it R of T and then I could use it. Desmos is actually nicer for the naming a little bit than the calculators are. So I ended up getting that negative number. So I'm going to write that negative number down, at least accurate to 3 decimal places. So it was negative 0.31362 whatever. We know that that is a negative number. It's less than 0. So if it's less than 0, that means that it had to be decreasing in the pipe. Okay, but it said that I had to give a reason for my answer. That is not giving a reason for your answer. Okay, so I have to figure that out a little bit. So I'm going to say something like, I keep hitting the button. Since R of 3 minus D of 3 is less than 0. That's a fancy way of saying that when we subtracted the rate in minus the rate out, it came out negative. Okay. The amount of water in the pipe All I'm doing is restating the question stem of water in the pipe is decreasing. What? Yes. At t equals 3 hours. Every time we ask any time they ask us to justify, there's usually a time involved. You always have to state the time. You always, if there's an interval, you always have to state the interval. Okay. So that's what that sentence should, that reasoning should look like. Any questions up to this point so far? So on this one, the points came from, you had to consider that, what did I do? I missed a step? No. Oh, I'm looking at the wrong set of points. I had to consider these guys. So that considering those guys and putting those in the problem was 1 point. And then my answer with my reason here was 1 point. Okay. So part C, okay. We're looking, it says, is the amount of water in the pipe, at what time t, between 0 and 8, is the amount of water in the pipe at a minimum, okay? So this is not talking about not just it doesn't say relative, so this is an absolute minimum, and we're supposed to justify our answer, okay? There's a couple things that we have to keep in mind. First of all, when we're talking about a minimum, that means I need to figure out I need to use my endpoints and any critical number in between, okay? So to get a critical number in between, I need to take a derivative, but I need to take a derivative of the total amount of water. So this one's gonna be a little bit crazy. So I gotta figure out how to get the total amount of water right now because I just have a rate. Well, first of all, I know before I turn the water on, there's 30 in there. So I got to start with 30. So I'm writing a function for the amount of water. So this is the amount of water function right here. Then I know that to get I add up or I integrate the rate, right? And that will get me back to my total. So when I integrate a rate, I get back to the total. So my total is R of X minus D of X, because I think they were in T's, weren't they? Let's leave them in T's. Actually, never mind. It doesn't matter. I kind of put a dummy variable in there, X, because eventually we want it in T's. We'll put a T up here. So I'm going to put a 0. We started 0, and we're going to end at some arbitrary time. I'm going to call that T dx. Okay. So again, these are kind of just what we call dummy variables. They're just kind of a placeholder. Kind of this one is 2, but we're going to eventually, when we integrate, we'll get our function back in terms of T. So that right there, recognizing that, that was worth 1 point on this problem. Oh, no, it wasn't yet. No points yet. Okay. So the next thing I have to do is now that I have the total amount of water, I have to take a derivative of this thing in order to find the minimum. All right. So what the derivative of 30 is 0. Okay. So I'm not going to write that. We know the derivative and the integral cancel. So I get what's inside, and then, but when I have this variable up here, I have to plug that variable in. So when I get my derivative is really R of T minus D of T, okay? And then we're gonna evaluate this. Oh no, I have to set that equal to 0, because that's how I get critical numbers. Because in order, if I'm gonna do a max or a min, I gotta have my critical numbers. So I need to know where R of T, equals and minus D of T equals 0. So again, I have these really complicated functions. If I had something simpler, I could look at a chart or a graph, but I'm going to go into my calculator. And I have it right here. I made that's what the picture looks like. I don't really need that, but here is my function. Okay. The first thing I had to, oh no, wait, I want that right now. Never mind. So I'm going to turn off my other ones because they're a little bit icky. So what I really want is between 0 and 8. I'm going to set my zoom, my x-axis between, I don't know, I'll go -1 and like 9, so we can see between 0 and 8. All right, so the only place I have zeros are at 0 and at 3.272, which really isn't accurate enough. I really need more decimals, but Desmos won't give them to me. So that's why I guess our calculators are better in that respect. We get more accurate answers. I know why it gives me a whole bunch over here, but only 3 in the graph. And I tried I looked up the help. I tried zooming in as much as I could. It still wouldn't give me more decimals. So these two numbers need to go in my t-chart. So I can make a t-chart, or I can do f of 0 equals f of 3.27 equals f of, we've done it kind of both ways. So I'm going to use the t-chart today. So I have t, and then I have the amount in the pipe. And this is my justification for an absolute maximum, is either writing f of whatever or putting it in a chart. So I'm going to put in, I know I need to calculate 0, 3.2. When I calculated it on the calculator, I got this number. It was a little bit better, 5.8, and then the end point 8. So this came from it being the end point that was in my original right up here. So I have to put the end points and any critical numbers I found from the graph. All right, well, we already know that when we put in 0, we get out an 8. So I kind of get that one for free. These two I need to put into my calculator, into the function we typed in. So I've got that function that we came up with right here. I'm going to start by putting in the 3.271658. So I get 27.9645. I'll write that down in a second. All right, and then the other number I have to put in is an 8, and I get 48.543686, and so on. Okay, so let me write those two numbers down over here for you. So the first one was 27.964561, and this one was 48.54388686. All right, so let's go back to make the question and make sure we've answered it. So it says, at what time is the amount of water in the pipe at a minimum? I think when we did this the other day, we talked about a value. It talked about a minimum value, but they didn't talk about the time. So this time they want this value over here versus here because they specifically asked for time. So they're looking for the smallest number. It looks like the smallest number is there, so that occurs at this time here. So we would write that into a sentence. So the amount of water, and again, I'm restating the question stem. Amount of water is a minimum. At t equals 3.27165. You're probably good there. And then that's measured in hours. Okay. Andy, we're almost ready for your joke. All right. We get any questions on that one? Okay, I'm going to scroll to part D. All right. So the pipe can hold 50 cubic feet of water before overflowing. Okay. Oh, Gabby, the 8 came from the endpoint. So you have to do, when you're doing absolute, you have to do your 2 endpoints. So the endpoints on here that they gave us in the interval, the endpoints of the interval, and any critical numbers in between. Any other comments? Where did the 8 come from, the amount? It came from so the 8 came, are we okay on that, Gabby? Let me know if I answered your question, okay? And then Sarah, it was 3.217 because this Y value here was the smallest and they were looking for the minimum. Any other questions on that part before I go on? Okay, I'm gonna keep going. All right, so I'm gonna read this again. So the pipe can hold 50 cubic feet of water before overflowing, okay? For T greater than 8, water continues to flow into and out of the pipe at the rates given until the pipe begins to overflow. Write but do not solve. Not evaluating. Those are like the most magical words ever when we see that on an AP test. You're going to see it somewhere, okay? An equation involving one or more integrals that gives the time W when the pipe will begin to overflow. Well, here's something really awesome. we already know, we came up with this equation up here. That tells us the total amount of water in the pipe. We're going to reuse that equation, okay? And we're going to put that, instead of integrating till the time, we're going to integrate, they gave us something here. We have to integrate, the time is going to be W. So we're going to integrate, so we're going to say the 30 plus the integral from 0 to W. And I'm going to put the t's back in, so R of t minus D of t. dt. Now, that's not an equation because they asked us to write an equation. That's just an expression. That's part of the equation. We have to figure out a mechanism to solve for W. So when I eventually integrate this, it'll be R of W minus D of W or whatever that is integrated. But they gave us what the total amount should be right there. So we're just going to set it equal to 50. And I forgot to do points on the last one. So I need to go back and do points. All right, we did points on, yeah, so we need to do points here. So the points on this one, you got a point here to consider that. You got a point for the answer, which was the time. And this here is really your justification, so you got a point there. And then down here, you get a point for the integral piece, and then 1 point for the entire equation. Okay, I'm going to go back. I see a question in the chat. So Madison, I'm going to go back to part B here. So a minimum, I'm going to flip this now because it's easier to write on. I don't need the calculator anymore. And then, of course, the calculator pops up. Okay. That's not the button I wanted. Okay, go away. Yes. All right, so a minimum. The minimum is the smallest y value. The maximum, and we're talking, remember, this is absolute, not relative. The absolute max is the largest or the biggest y value. Okay, so what we calculated here, these were the x values, these were the y values. So this number and this number were the endpoints. This is a critical number we got by setting our function equal to 0, which we calculated through the graph. This was an 8, right? So that number is bigger than, what happened? I see what the problem was now. It's because I wrote the wrong number right here. I see why you're all questioning me on this, and you should be. I have a typo. Look at what it says right here. T of 0 equals 30. So what? No, I should have put a 30 there. Now does this number make sense that that's the smallest? There we go. Gabby got my mistake. At least you guys are paying attention and awake on a Friday afternoon. So I appreciate that. All right, Andy, are you ready? Okay, come here. We have Andy's joke of the day. Please say things, you guys. When I screw up, you got to let me know. Okay, I'm only human. It's going to happen. I screw up like 400 times a day. Just don't tell my children.
I heard that.
Okay. All right, Andy, look into that one there. Okay.
Hi.
Okay, hi. Tell us your joke.
What's the best thing about Switzerland?
So he said, what's the best thing about Switzerland? All right, what is it, dude?
I don't know. But the flag is just big plus.
He says, I don't know, but the flag is just a big plus.
Oh, wow.
Oh. Did Donovan show up? Normally Donovan gives us some good feedback. Donovan didn't come.
Wow, Donovan.
All right, they all love it.
Bye.
All right, we'll see you in a little bit. All right, he has to look him up now. All right. Yeah, what did Donovan do? Is he sleeping, Zeta, instead of coming in and doing this with you? You should make him get up. All right. There's my wonderful picture for he is a dad joke king. Yes, he is. Oh, even Ellie is in here making laughing. All right.
I honestly don't know where he is.
Right,
This would be his type of joke.
It gives him something to do, let's put it that way. We're looking at 2016, number 5, and here's the deal. It looks kind of like we've done the cone problem. I've made you all experience that. And this year, a couple years ago, they came back and said, Mrs. Ballard, the cone looked really weird. Well, it wasn't a cone, it was a funnel. And it turns out that this picture has absolutely nothing to do with you actually doing the problem. There's absolutely nothing that you need that picture for, okay? So they give you the picture, but it's really kind of irrelevant, so I didn't like draw it 10 times. So the inside of a funnel height of 10 inches has a circular cross sections, okay? Yes, Melissa, just by adding the equals 50, we were done. Oh, there was one other catch on that one. Do you see this W right here? That was different, okay? So because we had to put it, it told us in the problem we had to put it in terms of W. Okay. So I'm going to read the problem again. So inside of the funnel height, the inside of a funnel height 10 inches has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by this. So this is our radius equation, where h is between 0 and 10. So that's our interval. We got to stick with that interval. The units of r and h are in inches. In part A, we're supposed to find the average value of the radius of the funnel. Okay. So if you are in AB, you don't have to do the average value this year. Okay, that's not on your test. If you're in BC, you do. I'm going to do it as we're going through it. It doesn't hurt the AB kids to know this. I did teach it to you. But I want you guys to focus more on, do you understand how it's being integrated than the average value part? Okay, BC, you need to understand the whole thing. All right. So what we're going to do is calculate the average radius. And whenever we see those words average value, that's the 1 over b minus a from a to b of whatever your function is. Okay. So, and it's average value. Average rate of change means derivative. That AB, you are responsible for average rate of change. Okay. So the average, so I know that this here is my interval. So I've got 1 over 10 minus 0. From 0 to 10. And then the function, I am going to have to integrate this by hand. This is a number 5, so it would be 1 without a calculator. So we've got 1 over 20, 3 plus h squared, and then we would say dh. All right, so I'm going to go ahead and I'm going to start integrate. Actually, I'm not going to integrate quite yet. I am going to choose to move, I'm going to do a couple things. This is really just 1/10, and I'm going to move that outside. So 1/10 times 1/20 would be 1/200 from 0 to 10 of 3 plus h squared dh. Now it looks a little bit nicer. I'm going to integrate that. So we've got 1 over 200. When I integrate the 3, I get 3h. When I integrate the h squared, I get h cubed over 3 from 0 to 10. Okay, we're going to plug in. Okay, so that's the next thing we have to do. So I'm going to plug, I'm keeping the 1 over 200 out front. 3 times 10 is 30, plus, maybe I don't know how to do 10 cubed in my head. I'm just going to write 10 cubed over 3. And then I'm going to subtract. I choose to bring this with me because sometimes we forget parentheses in weird places. And then we're going to do 3 times 0 plus 0 cubed over 3. Now, because this all turns out to be 0, you really don't need this part. But again, it's uncomfortable, but we are going to stop right there. I'm not going to try to do that without extra help, without making a mistake in my head, okay? Or even on paper if I've got the paper to write it on, okay? If you really, really need the answer, it's 109 over 60, and it really should be. You can label, even though this is funky looking, you can still label it in inches. All right. We're going to put on the points, okay? So setting up the integral, this guy right here, this integral setup, this would have gotten you 1 point. The antiderivative, so this line right here would have gotten you 1 point. And then this final answer right here, this weird number thing, would have gotten you 1 point. And again, who really likes to do that many fractions? None of us do. I don't. So I wouldn't try to get to this answer. I would definitely take advantage of that I get to stop and not simplify and do that answer, do this answer right here. Okay. Let's go to part B. Are we good on that? Any questions on that one before I move on? Nope. Okay. All right. So part B simply says find the volume of the funnel. All right. So the volume, remember, is, and I don't know that you would take you guys quite this far, but in AD, but it's not bad to look at the problem. I was really trying to, part C is the part that, well, that is I was trying to get out for the day with rates. If we have area and we need to get to volume, that means that we need to integrate to get there. Okay. If I had volume and I got to get to area, that means I have to take a derivative to get there. So I can get the area of it, or area of the kind of the cross sections of it. So we're basically, you integrate the area to get the volume. So, and I'll write that down. You're going to integrate the area of a circle to get volume. And let me explain that a little bit more, okay? I'm going to use the picture for that. So it kind of is touching on two different things. Kind of touching on what we call cross sections, which we didn't study. Some of you have probably watched the videos. BC, you have seen this. So really, what's going on is there's a circle right there, and then there's another circle right here, and another circle, and another circle, and another circle. Just like we add up all the little rectangles to get the sum of the area under the curve. To get the volume, we're going to add up all these little discs of circles, okay? And remember, when we do integration, it's a symbol for sum. We're adding things up, okay? So basically, I'm going to integrate the area to get the area of a bunch of circles to get the volume of this, this funnel. So the formula for area of a circle, hopefully you know this, is pi r squared.
Believe it or not, they're round.
Oh, Ellie just put an extra joke in there for the day. So Ellie, why aren't pi squared?
They're round.
She says they're round. All right. So if Ellie knows the area formula, you should know the area formula.
This morning.
Oh, she says she used it in her math homework this morning. Okay, so I'm going to basically plug into that and integrate that. So volume equals, I'm going to put the pi part on the outside of my integral. The radius they gave us right there. So 1/20, 3 plus h squared, and then this whole thing gets squared because the radius is supposed to be squared, dh. I'm still going on this interval here, 0 to 10. Okay, this one's ugly. All right, so, oh, we're missing pi day. When no one in 0 showed up to pi day. People showed up to pi day in 0 period. I don't know if Nate was there, but I can't remember. It was too long ago. All right. I know we had a lot of pi left over in, he was there half the class. That's about how much Nate's always there, though. It's true.
Ow.
All right. So Ellie is not thinking she wants to be in my class right now. So the where was I going with this? So I'm going to square things, okay? So I'm going to do a little bit of algebra stuff here. So first of all, if I square this piece here, I get 1/400, which I'm going to put out in front. So I'm going to take that coefficient and put it out in front as pi over 400. So this was 1/400. I put it in front as pi over 400, okay? On the inside, I'm going to write some scratch work off to the side here. 3 plus h squared. If I'm squaring that, that's a fancy word for, because I really don't want to have to do a chain rule. I'm sorry, a u substitution. Because I really don't have what I need there for a u substitution. So I'm actually going to FOIL that out. So let's see, 3 times 3 is 9. 3 times h squared is 3h squared. I've got 2 of those, and then plus h squared times h squared is h to the 4th. So inside here, I'm really integrating 9 plus 6h squared plus h to the 4th dh. So I just simplified it better before I actually integrate it. All right, so we've got pi over 400. And then when I integrate this, 9 would be 9h. When I integrate 6h squared, I get 6h cubed over 3, which is going to reduce to 2h cubed. When I integrate h to the 4th, I get h to the 5th over 5. And we're going from 0 to 10. The good news is I just have to plug the 10 and the 0 in, and I'm done. I don't really need to worry about what the answer looks like. So I've got pi over 400 times, I guess I could go 90. 9 times 10 is 90. Plus 2 times 10 cubed plus 10. I'm definitely not doing 10 to the 5th power. Even if I know I just have to add a bunch of zeros. I probably do not need to show the minus 0 part because everything's going to zero out. But if you do it, it doesn't hurt. Okay. They're not going to mark you down for it in any way. So plus 0, 0 to the 5th over 5. It's still correct. All right, stop there. I don't even want to know. It's Friday afternoon. I'm definitely not integrating that thing by hand. And then make sure I would probably label inches cubed at the end. Official answer, 2290 over 40 pi. Can you imagine doing that by hand? No, thank you. All right, the points. So we get a point for the integram. So 1 point in here. You get a point for your antiderivative. So you got a point for this. And then you get a point for this answer. Is that the blue one? It's green. Okay. All right. So today was kind of supposed to have a rate theme to it. Any questions on that one before I go to the last part? All right. Today was supposed to have a rate theme to it. So we're going to go to rates. Okay. So do a rate problem. Ellie Bell, can you check the roll real quick for me? Okay. One more time. Okay. Because I see we're up to 30 or 29 right now. Okay. So the funnel contains a liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches. So we know just at that instant. Okay. We can't put that in any sooner than the very last part of the problem. At the instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at a rate of. Okay, so first of all, rate means derivative, but remember we kind of like that word rate to be in the front. So it's the rate of the radius or the derivative of the radius. This word decreasing means that it's negative. So really what they're saying here is that dr dt equals -1/5 inches per second. And the other clue that you're in a rate or a derivative is look at that label. It's in definitely a rate label. Okay, inches per something, feet per something, per time is always a rate. At this instant, what is the rate of change? Okay, so it says rate of change. That's a derivative of the height. So you're looking for dh dt. That's what we've got to find. It says the height of the liquid with respect to time. So it's always, the t is always going to be on the bottom. All right, so we have a formula or a function. We're going to go ahead and just take its derivative. Okay. I am going to choose to distribute that 1/20th in before I take my derivative. So I have r equals 3/20 plus 1/20 h squared. All right, what's the derivative of 3/20? It would be 0, right? So I'm not even going to write it down. The derivative of this, I bring the 2 in front. So I've got 2 over 20. I missed something in the front of this. It should be dr dt equals 2 over 20 h times dh dt. Remember that when we're doing rates, we do them implicitly. Okay, so we want to make sure we use the dr dt, the dh dt, the dy dx if we need to. All right, I'm ready to plug in my values because I'm supposed to be solving for something. So I'm looking, do I have dr dt? Yep, it's right there. So I'm plugging in -1/5. I'm going to choose to reduce that to 1/10. Do I have h? Well, yep, they gave me an h for at that moment, so it's 3. And then dh dt. Now, I don't have to simplify it all the way, but I do need to get dh dt by itself. So you're telling me what it's equivalent to. Probably, as a good mathematician, I would probably try to simplify it. I know that that's really 3/10. And then to get this to the other side, I would multiply by the reciprocal. Now, right there, you can stop, but you do need to label it in inches per second. Okay? For those of us that really need it simplified, it's negative 2/3 inches per second. Any questions on that part? All right, Andy, come on back in. Okay, so we're going to play two Kahoots. Okay? Andy's going to be the Kahoot administrator, but I'm going to give you guys like 3 or 4 minutes here. One of the Kahoots has 10 questions about Ellie. Some of them you'll probably be able to get just from looking at the pictures in the Kahoot. But if there's any, they're not pictures of you. They're not pictures of you. Okay, no, not many. So come on over here, Ellie. Do you guys have any questions you want to ask Ellie? You put them in the chat, or you can come off your microphone and she'll tell you the answers to them. Melissa says, what's your favorite subject?
What do you mean by subject?
Like math, English, social studies?
No.
Come on over here.
I don't know. Definitely not English and history.
Definitely not English and history. What's your favorite subject? What's your favorite class to go to during the day?
Math and drama.
Math and drama. What's your favorite color?
Teal and purple.
Teal and purple. Okay. Does your mom bring math up a lot?
Yes. First thing when I walked down the stairs today. So Ellie, have you gotten your math assignments done already? She's already asking me about math.
Oh. Any other questions for Ellie?
Her career choice.
That noise. Jeez.
Weirdo.
Do you like playing flute, or would you switch instruments?
It depends what instrument I would switch to.
If you wanted to switch instruments, what would you switch to? She played violin for a while. Piano. She's doing a really good job on the piano. Mommy bought them an app that wasn't cheap, but they're both the kids are playing piano, and they're doing a really good job.
I haven't gotten to play in like 3 weeks.
All right. What's your favorite movie?
Favorite movie? High School Musical.
High School Musical. What's your favorite?
1 and 2.
1 and 2. What's your favorite Disney character?
Stitch.
Stitch. Okay. Any other questions for Ellie?
Wait, how do they know that I'm playing the flute?
Sarah played in the band. We've talked about it. What about your favorite Disney princess?
I don't know. Belle.
Belle. What does she want? What do you want to be when you grow up?
A human.
A human. Can you see the middle school sass has set in?
Breathing.
Favorite video game?
Minecraft.
We don't play very often around here.
Minecraft. Oh, I used to play for hours.
She did used to play for hours when she was in elementary school, but not in the last year.
My friends and I would come home and all we do is play Minecraft.
Yes, all we do.
Like, we wouldn't even take off our shoes or take off our backpacks. Like, we just go straight to play Minecraft.
Yes. That's where it's at now. It says favorite animal.
Elephant.
An elephant. When she was a baby, she had this onesie that said Elephant Ellie. I still have it somewhere.
Yeah, you do. Dude. Excuse me.
All right. Any other questions? We'll give you like 30 seconds to ask a question.
27, 26, 25, 25.
Will you be majoring in a math-related field when you're older?
Maybe.
Like math, science, or do you want to major in drama still?
Something theater like your band.
She likes theater and band. That's kind of her wheelhouse right now. She's been acting since she was 1. So.
But I definitely want to do more math though.
She likes to do more math. Not right now. She's tired of math at home. She's got a lot of math homework.
I'm tired of math.
Those math teachers really lay on the homework.
Yeah. Like you.
All right. Yep, like me. It's a bummer. Okay.
My friends always said that they
What's
felt
your
sorry
dream
for
job?
me.
Blanca asks.
Something like theater related or like band.
We can tell you what mom and dad think she's going to be, but you know, she doesn't like that idea.
A teacher.
Mom and dad think she's going to be a teacher.
Last summer she said she thought I was going to be a teacher because I like school supplies.
She does like school supplies.
It's not a bad problem to have, you know.
It is a bad problem to have, but that's a good sure sign of a teacher. Okay. I'm fixing something on one of them here, and then we will play.
Oh,
if you have any last
there's
second,
a picture of me.
just one. Shh. Okay, I got to fix something here because you gave an answer that I didn't have in here. That was, I need to make that one. Uh-oh.
Oh,
I got to edit. Fixing something. Oh, Naomi says she's obsessed with school supplies too. So maybe
See,
Naomi's,
it's not a bad problem, Mom.
it might be, I didn't say it was a bad problem. Okay, I'll go there. Okay, we've got it fixed. We're gonna hit done. Okay, we're gonna share the screen. Okay, so Ellie's not gonna play this round. So everybody go to
I'd win.
I'm gonna share my screen again. Teach.
Wait, is this Ellie's?
Yeah, this is the one about Ellie. Okay.
I need to get in.
Oh, Andy's gonna get in, he says. Oh, what's your favorite food? Andrew's asking.
The birthday cake I had last night.
The birthday cake she had last night. Mommy
It was delicious.
I made a brownie base because she doesn't like cake
delicious.
with ice cream layer and a chocolate ganache top. So.
Hey guys, I'm coming in.
All right, so here comes Andy. He's gonna get on with you. Everybody go to kahoot.it.
I go get my phone.
Yeah, go get your phone. Okay. It was kind of fancy, and the preschoolers helped me make it, so you can imagine what it looked like. I blamed how it looked on them. Usually I make a pretty good looking cake. All right, so here we go. My Kahoot is hopefully going. Nope, not that one. There we go. Okay, we're gonna hit classic. All right. You kidding? Baking is all about the numbers. I also sew in addition to baking. I can cook pretty well too.
Wait, Mom.
We don't go hungry around here.
Wait, Mom, do I have to join the Zoom to see the answers?
You can come over here on my side.
Okay. What's the game pin?
Come over here.
8264842.
No, back. 824.
8264.
264.
8264-842.
842.
Okay, make sure you put a name in there that I recognize so I can get you points.
That's like tiny. That's like Tiny Ballard.
Tiny Ballard.
Except for
That's what your students
young
call me
ones.
whenever I go on campus.
They call you Tiny Ballard.
Yeah, they
It's
say, hey.
Maribel Tacos today. I don't know how Connor gets the little dog by his name.
You go to the emojis, Mom.
There's emojis on your keyboard?
Yes.
Where? On here on your keyboard?
Yes.
All
I
right.
think you don't know this. I always play off my phone, so I just get all the emojis that I call.
I didn't know you could do that. All right, Andy, are you in there, dude?
I'm almost there.
All right.
Today, it was Ellie ice cream and Ellie sunflower.
Yeah. Okay. All right, hurry up, Andy.
Hurry up!
All right. We'll see if you guys can beat Andy because Andy's gonna play.
And I know a lot about Ellie.
He does know a lot about Ellie. He plays.
And
Andy, aka Taco.
Okay. Apparently he's a taco as well.
hi,
Thank you for interest. He knows what AKA means too. All right, here we go. We're gonna start. Okay, if you're not in, the code is in. Okay. You're gonna have to.
Andy, you can go play off of my computer.
Oh, can he see the thing going over there?
Yeah.
Okay, go over to Ellie's computer.
Go
Or here, you can do it from here.
in the pictures.
Okay.
What?
Keep in mind so this isn't a question. Just keep in mind there's a lot of hints in the pictures today. Okay. How old is Ellie? Well, yesterday, but today.
Yes.
I'm gonna laugh. It's wrong. I'm gonna laugh so hard. 14? What on earth?
Sorry, Ellie.
What?
Let's see.
I went behind you. Oh,
Andy's
sorry.
third.
All right, Andy's only in third place, so the delay isn't that bad.
Honestly, I want Andy.
Okay,
That'll be funny.
Ellie's favorite treat.
Ooh. What's that one?
Chocolate.
What's that one? Ooh. I like
What's
that
the answer?
one.
Yeah, you like that
I like that one. Bacon. That's delicious. I don't like those.
There we go.
Yay!
She loves donuts, maple bars specifically, but everything
With
donuts
bacon on top.
with bacon on top isn't bad.
Oh,
Oh, Andy's winning. All
I
right.
jinxed it.
What's Ellie's favorite movie?
Jinxed it, Mom. Hey, I found the right picture.
Of course I did.
Yes.
Oh, Michaela says that's her favorite donut too.
Those are all big.
They're all good movies. Those are all ones we watch all the time. Good job, 100%.
They all cheated. They all cheated. They asked me, and then you showed them a picture. They all cheated.
No. How many brothers does Ellie have?
Too many. Yes. Andy, that's not fair. That's not fair for Andy. That's not fair. Why? I can take all the answers.
You should, your brother. All right, she does have 3
23.
brothers.
23. I knew
23
that.
got it right.
Get it? No.
4 people thought you had 2, and 3 people thought you had, what did I say? Oh,
2.
had 4. They did the number of kids. All right.
Yes.
Gabby and Michaela are rocking it today.
Oh,
What was on TV when Ellie was born? We've actually done this one in class. Oh, I didn't do the.
Really?
Apparently, I gave the answer away because I didn't shade the thing. That's a good one.
Last night was the NFL draft.
Every year we take her picture in front of it.
No, different house every year. Okay.
I didn't do the thing.
I Notre Dame football game.
It didn't work.
Fixer upper, Notre Dame football game.
It was Final Jeopardy. I think we've done that one in class. All right. Oh, Miguel moved
You're
up.
not gonna get me, Miguel.
Okay, shh.
Multi-select.
Okay, Ellie's after-school activities include which 2? Dance, drama, softball, cross country.
Oh my gosh, this is hard.
You got to pick 2.
Drama, softball. Guess I got it wrong.
Dance and drama.
Stop.
Okay, here we
My
go.
bean.
Oh, we kicked Andy out of first place. All right. He's super happy about that.
No.
Okay. A nickname that Ellie's dad used to call her.
He still calls it me. There are a couple of them.
Well, what dad calls her. That's what's different. No.
There's also another one. There's also another
Joe,
one.
put your whole eyes.
Yes.
Stop.
You used to call her Tinkerbell.
Uh-huh.
Mommy calls her Ellie Bell a lot, though.
I'm
That's
in
what Mommy
this
calls
place,
her.
people. I'm gonna get you.
Wait, how many people
Wait.
got that right?
I did like 7. All right, here we go. Multi-select. What is Ellie's favorite color?
I'm gonna laugh if they get this wrong.
I knew.
That'd be funny.
They already know.
Exactly. It's wrong.
Yeah.
And I gave them the answer. Yeah.
All right, teal and purple.
Casey.
Okay, we got a lot of movement. Good job, guys. Okay, last one. Where is the first place Ellie wants to go when we can leave the house again?
Oh
Five Guys, Disneyland, Costco, or Grandma's
Definitely
house?
not there. Definitely not there. Nobody wants to be there.
No Five Guys.
There we go. Everybody got it.
Whoa.
All right. 2 people said Grandma's house.
That's true.
Come on, I got you.
Oh, they are coming in.
All right, here we go. The podium for Happy Birthday, Ellie. Happy third.
Andy's in the top 5.
Keon is in second. And who made it to first? C made it to first. Good job. And we got Andy and Knock in 4th and 5th. Good job. All right, Ellie, go get on. Okay, we're going to play one more.
The game.
We will play one more. Andy's going to run the game this time. Oh, you're getting on your phone?
Yeah.
Okay, so this one is a Disney or a Pixar
I
one.
need to see.
I'm sitting in this chair.
All right, here we
I'm
go.
sitting in this chair, Mom.
I know, I'm going to get it going and then I will. All right.
Thank you. It's out of
Miss
my
Ballard?
chair.
Hey, I can't see.
It's out of my chair.
What's
Mom.
wrong?
Oh, that was Gabby from 3rd period.
Yes, what's
Just-
wrong, Gabby?
Oh no, it was just
Nice.
because I
Okay.
know there's 2 Gabbies.
All right. Okay, so everybody get in there again. Play with I'm moving Andy. This one's more kind of Pixar movie related. We'll see if you can beat Ellie.
Hopefully she doesn't
See,
get.
this is what does it. I'm gonna play when I'm ready to play.
That's kind of cool.
Yeah, it's so cool. Oh yeah, in one of my Kahoots that I played in, they had Schoolhouse Rock. Literally.
All right, how many people have been?
27.
20. Okay,
Last play that checked in was
20 seconds. 20 seconds. I'm gonna start.
20, 19, 18. Hey, Maribel Tacos! Thank you, Maribel!
It's a good taco.
Yeah, I started. Huh?
Oh, Maribel had it last time too. All right.
Ellie's sunflower.
See, Tom's in there. He's got his little puppy dog. Okay, let's go.
All right.
And he's gonna start it up.
Pixar films. 3, 2, 1. Quiz. Which character does not appear in Toy Story 3? Sid, Mr. Potato Head, Bo Peep, or Slinky Dog? Steven.
Yeah, there's a Toy Story novel on that one.
I already know this one. Bo Peep.
Oh,
That
Toy Story
is
3
correct.
Bo Peep.
Bo Peep
Sid
wasn't
is in the garbage truck. He's the garbage man.
I know.
Okay.
Sid.
All right.
All right.
Next.
Rice. Nice. Connor,
All right,
I love you.
Keep going.
Quiz. Who is Mr. Incredible's best friend's name? Ozone, Mr. Freeze, Mr. Ice, or Frozone?
Stop spitting at me.
Mr. Ice. I definitely know who this is. Frozone! It is totally Frozen.
Okay.
Ozone. Oh my gosh. That was
Okay, Andy,
an
no
O-O.
commentary.
He can't.
Oh, Maribel
Alright.
Tacos. Quiz. In Monsters Inc., the city powered by Scream. By the
Oh,
end,
I
they
know this, I
decide
know
to
this.
power it by
I know this.
children's sky, water, electricity, children's laughter.
I like how like was already answered before you're done talking.
Yeah, you're not one of them. Yes, I was. Just kidding. Yes, children's laughter.
Alright,
Come on, it's not children's cry. Melissa. Quiz. After Nemo is captured, he ends up in a fish tank at what business? A dentist's office, a hospital, a police station, or a pet store? Probably got, you guys are probably all. 3, 2, 1, 0. Yes, a dentist's office. Yeah, they are kind of pets,
Oh,
but
Ellie,
they're.
Ellie says she's up to 5th.
Oh no! Watch out for
I'm coming
Ellie.
to get you.
Oh, Bryce is good at this.
Wow. Quiz. In the movie Cars, Radiator Springs becomes deserted because a new mayor took over the city. A highway was built around it. The city kept losing races, and most of the cars moved west. Oh, yeah, I know.
How did it go for?
Yes, a highway was built around it.
How am I 11th?
Because you didn't answer.
I get it, Andy.
Oh, everybody's staying
Can I
safe.
come over to anyone else's house?
Quiz. Before Remy left to become a cook, what was his job among his family? To make the family meals, to smell food for poison, to search through the garbage, or to check for rat traps?
Oh, that's a bad life. Checking for rat traps.
Yeah, you could get killed by one if your mouse. 3, 2, 1. Yes, to smell for poison. What?
Okay, keep going.
Oh my god. Whoa, Madison,
Oh, Bryce
Bryce!
got knocked out.
Bryce! Oh my gosh. Madison,
All
you
right,
gotta
keep going, Andy boy.
Quiz. At the beginning of Wall-E, it is explained that Earth becomes abandoned because it becomes covered in trash. It ran out of water. It is taken over by robots. A meteor destroyed it. Oh, because it gets covered in trash. Okay. Quiz. In the movie Brave, Merida returns her mother into what animal? Oh, I knew this one. A duck, a swan, a rabbit, a bear. I know this because I watched the preview. And it was a bear.
Just because you watched the preview.
Yes,
You've
it
seen
had
the
that.
movie.
I've
Not
seen
much.
the movie.
Not much, but you've seen it.
Okay. 903. In A Bug's Life, Helmich, the caterpillar, main goal throughout the movie is to not starve, to become a butterfly, to find caterpillar friends, or to lose weight. Why could insect lose weight?
Funny.
Yeah, that's funny. Yes, to become a butterfly.
I actually did not know that.
Whoa.
Robbie says she loves Jeopardy and that you should join cross country.
Oh my gosh. I want to too. 10-13. Name this bird. Cuckoo, Birdie, Kevin, Sam. I already know this because I've watched the movie.
What movie is it from, Andy?
Up. Up, up, and away.
It's one of their new favorites.
Kevin. Someone choose Cuckoo. That would be a mean name.
That's because the species in the movies is a cuckoo bird or whatever.
Okay.
All right, keep going.
11-13. Name this character from the movie
Oh,
Inside Out. Sarah, Jessica, Amy, Riley.
I'll put that face. That face could be me.
This could be you.
Yes, Riley. Someone picked Sarah for some reason.
Because it's a name.
Okay, keep going. They may have hit the wrong color.
Ooh, nice.
Okay, hasn't been a whole lot of movement.
Wow.
Keep going.
Wow, they're stuck. 12-13. In Monsters University, Mike and Sully are kicked out, but how did they become scarabs? They went to another college. A friend from college helped them. Their professors recommended them. They worked their way up to from the mailroom. That's such mean things. But there is one that is correct.
Why wouldn't there be Andy?
They worked their way up from the mailroom. I did not even know that. That did not even show up. Whoa, somebody just took another person's place. I could see. 13-13. In Toy Story 2, why is Woody left behind while Andy goes to camp? Andy doesn't want him to get damaged. Andy rather take Buzz. And he thinks he's too old for toys, and he wants to leave him with his sister. I know which one. Oh, oh,
Would it be a good idea to let
Four.
your sister?
3, 2, 1. I do not trust my sister with my toys. Andy doesn't want him to get damaged. He got damaged before he gone to camp.
Can you tell that he's seen this movie before?
All right, let's see where we're at.
Sierra plus Duke.
Sierra plus Duke. She had the sunflower.
Rice.
Rice.
And I know which one.
And
Lorenzo.
okay.
Madison and Miguel.
All right. Again, another one. All right. So
Goodbye.
excuse me. All right. We will do another one tomorrow because I know we have nothing better to do on it. Right? Well, Sarah says she wants a refund.
Refund.
All right. So I'm going to stop presenting. All right. It was great to see you guys again today. Okay. We will probably pick on some more rate-ish. They like your commentary. Okay.
Thanks.
I'm glad we provide entertainment.
Thank you.
We
Can we do some more on Saturday?
we can do some more tomorrow. Okay. We will find another one tomorrow.
Wait.
Oh yes.
Oh.
Naomi, just remember, I live with him.
And also, we're gonna go into
And
the
two
pool.
other small boys. So the three of them. But his commentary is great. You should hear him play with his toys. So there are all kinds of stories.
And even
I do live with
think
you
I'm
too,
in
sweetheart.
live.
So.
I'm on live TV, so.
All right. And Melissa says that I can come over.
Okay. Yeah, you can.
All right. I'm going to let you guys go because I know you all probably have dinner and food to get to at some point here, and I have to go make dinner.
We got new goggles.
All right. I'm glad that we are great entertainment for you guys. I will see you guys all tomorrow. I can't remember what time tomorrow is. Hang on. I'll look real quick. Tomorrow is at 3 o'clock. Okay. And BC, you guys are at 2 o'clock. All right. I will try to get out what questions we have.
Oh, we forgot the joke of the day.
We did do the joke of the day. It was about the flag, remember? Okay. And Andy will have more jokes tomorrow. Okay.
Yeah, still searching.
All right. We will talk to you guys tomorrow. I'll see you then.
Bye-bye.
All right, bye.
Where's everyone?
Bye.
Maybe